All right, so in this section, we're going to be talking about some final types of probability and counting. So we're going to start off in this section discussing permutation. Now, there's a lot of different forms of permutation, but a permutation is an ordered arrangement of objects. So the key word here is that they have to be ordered. Okay, so order and rank are going to be important. The different number of permutations of n distinct objects is is denoted with using this the symbol n with an exclamation point, and it's read as n factorial. Now, what this tells us is that n factorial is equal to it's n times n minus 1 times n minus 2 times, and we're going to keep this trend going all the way down to 3 times 2 times 1. Okay, so an example of this, if I were to ask you to find 5 factorial, okay, this is the exact same as saying 5 times 4 times 3 times 2 times 1. Okay. So in example 1, it says the Big 12 Collegiate Athletic Conference with 10 schools and a list of schools here. We want to know how many different final standings are possible for the Big 12's football teams. Okay, so we have a total of 10 schools. Okay, so to find the total number is simply going to be 10 factorial, right? Because rank is important. We can rank these teams, okay, which is the same as 10 times 9 times 8 times 7 times 6 times 5, 4, 3, 2, and 1. Okay, when we multiply these out, we get a total of 3,628,800 possibilities. So possible rankings. Okay. So that's all we have to do here. Again, you're going to use your calculator for this. In class, I'll show you how to do this strictly using your calculator. Okay, and so the next thing we're going to talk about as far as permutations go is we want to find the permutations of n objects taken r at a time. So in this case, we're going to have several possibilities, but we're only choosing 3 or 4 or 5 of those possibilities. Okay, and we denote that by this equation here. Okay, so it's read as n chosen r at a time is equal to n factorial divided by n minus r factorial, where the number of choices that we make is less than the total number of participants. Okay, so in example 2, it says a psychologist shows a list of 8 activities to a subject in an experiment. How many ways can the subject pick the first, second, and third activity? So notice that we do have ranking here. Okay, so the way we're going to write this is we're finding we have 8 total activities, so n is equal to 8. Okay, and then we're looking at how many choices we need to make, so r is equal to, well, we have a first, second, and third, so we have 3 choices to make. Okay, when we write this out, it's going to be 8 P3 is equal to, okay, n goes on top, so we've got 8 factorial over 8 minus 3 factorial. Okay, simplifying this, we have 8 factorial over, this would be 5 factorial. Okay, and to compute this, what we can do is we can multiply the top number. Notice that the 8 factorial should be bigger than 5 factorial. So I'm going to multiply this out. So I've got 8 times 7 times 6 times, and the last one I'm going to just stop at whatever the bottom number is. So times 5 factorial all over 5 factorial. Now, notice that if I were to actually divide these, 5 factorial is 5 times 4 times 3 times 2 times 1 over 5 times 4 times 3 times 2 times 1. Notice that each of these divide out to be 1. So instead of having to write this over and over again, we can simply go down to the lower term and cancel them out. So now what we're left with is the beginning, so 8 times 7 times 6. And when we multiply this out, we get a total of 336 possibilities. Okay. All right, so example 3, it says the board of directors has 12 members. Okay, so this is our n equals 12. One of the members is president, one is vice president, and the other, another is secretary, and another is treasurer. So we have 4 positions, so R would be 4. Now again, order matters because we have a ranking system, president, vice president, secretary, and treasurer. We want to know how many of these positions how many different ways we can assign positions. Okay, so setting this up, we have 12 P4 is equal to, this would be 12 factorial over 12 minus 4 factorial. Okay, so that would give us 12 factorial over 8 factorial. Okay, and I'm going to leave the calculations to you guys. And again, I'll show you guys how to do this in the on the calculator when we get back to school. So calculating this, we get 11,880 possibilities. Okay. Okay, so distinguishable permutations. The number of distinguishable permutations of n objects where n1 are of one type, n2 are of another type, and so on, can be written using this equation here, or this formula here, where n is equal to the sum of the bottom row. Okay, so the key word here is this distinguishable permutations. Okay, so we have different aspects. So example 4. The contractor wants to plant 6 oak trees, 9 maple trees, 5 poplar trees along a subdivision street. The trees are evenly spaced. We want to know how many different ways they can plant the trees. Okay, so these are distinguishable ways. Again, here is your keyword. Okay, and we're going to pull parts out of this. So we have N1 would be 6, N2 would be 9, N3 would be 5. Okay, that means that N is equal to, remember, it's the sum of each part. So we have N would be 6 plus 9 plus 5, which gives us a total of 20 trees that we can plant. Okay, so we're going to work this out. We've got 20 factorial over 6 factorial times 9 factorial times 5 factorial. Okay, again, using your calculator, we will get a total of 77,597,520 distinguishable ways. So different ways that we can plant these trees. Okay. So now we're going to move on to combinations. So combinations, you'll notice that the equation down here looks very similar to the equation of the permutation. Now the only difference is this end. So we have the r factorial at the end. Okay, so combinations is the number of objects are selected from a group of n objects without regard to order. Okay, so this is where we don't care about order, and that's why we're dividing by the r factorial so that we can take the order out of our permutations. Okay, and so the way we work this out, we'll do example number 5. It says the manager of an accounting department wants to form a 3-person advisory team from 20 employees in the department. How many ways can the manager choose this committee? So notice that we don't care. We don't have rankings. We don't have positions. It's just a 3-person advisory committee. Okay, so we're just picking 3 people. So now we need to find what n is, and we need to know what r is. In this case, n is 20, and r would be the 3-person team, so it's 3. Okay, so we have 20 choose 3 is equal to, it's 20 factorial over n minus r, so 20 minus 3 would be 17 factorial times r, which would be 3 factorial. Okay, multiplying this out, again, I'm going to leave this to your calculator. We get 1,140 ways that we can choose this 3-person committee. Now, if we added rank into this, so if we cared who the first, second, and third person was, this number would actually be much larger. Okay, so we've learned a few different counting principles. So the first one was the fundamental counting principle. Remember that if we have n and m number of ways, we can find the total number of outcomes by multiplying m and n. Okay, in this section, we learned what factorial was. Okay, so remember factorial is just n times n minus 1 times n minus 2 times, and we keep doing that until we get down to 3 times 2 times 1. Okay, then we have, if we start looking at choosing a certain number out of a total, we then look at permutations. Okay, so that's going to be n factorial over n minus r factorial. Okay, and then we're going to look at distinguishable ways, so that would be n factorial over n sub 1 factorial times n sub 2 factorial times, and we keep going until we get to n sub k factorial, okay, where n is equal to n1 plus n2 plus, and we keep going up to, again, plus n sub k. Okay, and then finally, we have combinations where order does not matter. So we're not ranking these. So it's going to be n factorial divided by n minus r factorial, and we're going to divide out the choices. Okay, so again, the key here is this one. It's ranked or ordered. Okay, this one is not ranked or ordered. Okay, so we don't care about rank or order in this case. We're just choosing a certain number of people. Okay, so we're going to finish this off by kind of putting everything together. So it says a student advisory board consists of 20 members. Okay, so we have 20 members. 2 members will be chosen to serve on the board's chair and secretary. Okay, so using this sentence, we can kind of determine that order does matter in this case. Each member is equally likely to serve in each position. What is the probability? So now we're kind of throwing in some probability here. What is the probability of randomly selecting the 2 members who will be chosen from the board? Okay, so the way we're going to do this is by we're going to first of all find how many possible outcomes we have. So to do that, we have order does matter, so we're using permutation. So this would be 20 members choosing 2. Okay, so we're choosing 2. Okay, so that would be 20 factorial divided by 20 minus 2 factorial. Okay, that would be 20 factorial divided by 18 factorial. When you do this, you get a total of 380 possible outcomes. Okay, but we're looking for the probability of randomly selecting the 2 members of the board. So we're looking for the probability of selecting 2 members. Okay, so to select exactly those 2 members, we have one option out of the 380 possibilities. Okay, and when we divide these, we get about 0.003, or about 0.3%. Okay, so we're choosing one option, one of the possibilities out of the 380 total possibilities. Okay, so let's look at this next example. It says we want to find the probability of being dealt 5 diamonds from a standard deck of playing cards that also includes the jokers. In this case, the joker is considered to be a wild card that can be used to represent any card in the deck. Okay, so the first thing, we need to know what n is. So n would be, well, a standard deck has 52, and we're including the 2 jokers, so we actually have 54 cards in the deck. Okay, and we're choosing 5. Okay, so the first thing we're going to look at is what the probability, or how many outcomes we could have of choosing the 5 diamonds from the deck. So we're going to notice that we don't care about order here. There are a total of 15 possible diamonds in the deck. Okay, and we're combining that with, we're choosing 5. Okay, so we just want 5 of the 15 possible diamonds. So this would be equal to 15 factorial divided by, well, this would be 10 factorial times 5 factorial. And when we do this, we get 3,003. Okay, so again, this is the number of outcomes that we want, right? So we're trying to choose 5 diamonds out of the 15 possible. Okay, now we need to look at the total possible outcomes that we could draw, right? So we have a total of 54 cards in our deck, and we want to choose 5 of those. Okay, so this would be 54 factorial divided by 54 minus 5 would be 49 factorial times 5 factorial. Okay, using our calculator, you get a total of, what is that, 3,162,510 possible outcomes. Okay, so again, we found the number of outcomes that we want. We found the total possible number of outcomes. Okay, so to find the probability of 5 diamonds, we simply divide the two. So we're going to say 3,003 divided by 3,162,510. Okay, use our calculator to find the decimal. We get 0.0009. So a very, very small chance that we'll draw 5 diamonds. Okay. So the last one, it says a jury consists of 5 men and 7 women. 3 jury members are selected at random for an interview. Find the probability that all 3 are men. Okay, so in this case, we're just selecting 3 members. Okay, so we don't care about the order. Okay, now to find the probability here, we're going to have to do something a little bit different. So to find the top, so the number of possibilities that we want, we're going to have to multiply combinations. So we have 5 men, and we want to choose 3 of those, okay? Which means that we're going to multiply that by, well, we have 7 women, and we don't want any of those. When we do this, we have, this would be 5 factorial over 2 factorial times 3 factorial times, this would be 7 factorial over, this would be 7 factorial times 0 factorial. 0 factorial, if you read the textbook, 0 factorial is 1. Okay, so what we have here is, using our calculator again, we get a total of 10 possible outcomes. Okay, now for the bottom, we have a total of how many people? We have 12 people, and we're choosing 3 out of the 12. And again, setting this up, we have 12 factorial over, this would be 9 factorial times 3 factorial is equal to, and we get 220 possible outcomes. Okay, so to find the probability that all 3 are men, it's simply the total number of possibilities that we want divided by the total number of possibilities